Now let us see Doppler's effect in light. Usually Doppler effect is a effect or the phenomenon observed when a object or there are two interfering objects, their velocity changes, the apparent frequency heard, whether it is for sound or the apparent frequency observed by light, is different from the actual frequency possessed by the light or the sound due to the relative motion of the sound source and the observer. So Doppler effect definition is the change in frequency due to the relative motion of the object and the observer. So here light is an object or a source, and the observer, whether he is moving towards the object or moving away from the object, he tends to receive or he tends to see apparently a different frequency which is different to a actual frequency. There are two types of Doppler shift in light waves. First one is the red shift. First one is the red shift. That is when the observer or the light source moving away from each other. If the light source is stationary, if the observer is moving fast away, he tends to receive decrease in frequency. So apparent frequency f dash is equal to f into 1 minus v by c. This is a decrease in frequency. Here apparent frequency is lesser than the actual frequency. Actual frequency, where f dash is apparent frequency and f is natural or actual frequency. Natural or actual frequency. Now what about the wavelength? For a progressive wave, here light wave, c is equal to nu lambda. Since c is a constant, c by nu is lambda, so frequency and wavelength are inversely proportional to each other. Hence, for the wavelength, apparent wavelength lambda dash, wavelength lambda dash is equal to actual wavelength lambda 1 plus v by c. So when the apparent frequency decreases, that means apparent wavelength is more than the actual wavelength. That means you are moving towards higher wavelength. What you tend to see as an optical illusion is higher wavelength. Which is a higher wavelength in the visible region? The red light wavelength. That is why the observer is moving towards a higher wavelength or towards the red wavelength. That is why that shift, apparent shift in the frequency, where there is a decrease in frequency and increase in wavelength, it is called red shift. So it happens if observer moves away from the source or source moves away from the observer. Source moves away from the observer. Next, second is the blue shift. The second one is the blue shift. This takes place when observer or source moves towards each other. Where if the observer moves towards the source or source moves towards observer. moves towards the observer. That is called blue shift. So, now we can guess the apparent frequency should be more than the actual frequency. So, same apparent frequency is f dash, same notations I am going to use. So, that is f dash is equal to f into 1 plus v by c. Clearly in both the cases, v is velocity of the source, velocity of light source, and c is velocity of light. Or if the source is stationary, then it should be velocity of the object or the observer moving. If the light source is stationary, v should be the velocity of the observer or the object moving. Clearly apparent shift, there will be apparent shift such that frequency increases. So, when the frequency increases, you are coming back. So, this is Vibgyor, violet and indigo, they do not they do not form a color, because by Rayleigh's law of scattering they will be scattered all over. Only blue can be seen by us. Okay, that is why you are moving towards higher frequency, lesser wavelength. You are moving towards higher frequency, lesser wavelength, that is towards blue. If you are moving towards higher wavelength, then the shift is red. Okay, so apparent frequency when it is greater than actual frequency, when that can happen? When the observer is approaching the source of light or the source is approaching the stationary observer. So, apparent wavelength will be lambda dash is equal to lambda into 1 minus V by C. So, this is about blue shift and red shift. Here clearly in red shift apparent frequency is lesser than actual frequency, apparent wavelength is more than actual wavelength. Whereas in blue shift you are moving towards higher frequency where apparent frequency is more than actual frequency, and apparent wavelength lambda dash is less than actual wavelength lambda. In Doppler shift, the fractional change in frequency to the actual frequency can be given by the formula. Suppose in red shift, obviously the apparent frequency is less than the actual frequency. The formula is f dash is equal to f into 1 minus v by c, which can be related as f minus fv by c. So fv by c is f minus f dash, v by c is f minus f dash by f, which is delta f by f. So, this is one formula. Similarly, but clearly f dash is less than f, that is apparent frequency is less than actual frequency. Similarly with the wavelength, lambda dash is equal to lambda into 1 plus v by c. So, that can be expanded and written as lambda plus lambda v by c. So, lambda dash minus lambda is lambda v by c. This is delta lambda. Lambda dash minus lambda is delta lambda, that is change in wavelength. Apparent wavelength minus actual wavelength, change in wavelength to the original wavelength. So, this is fractional change in wavelength, this is fractional change in wavelength. So this is delta lambda by lambda is equal to V by C. Similarly, fractional change in frequency. Similarly, in blue shift, if I write fast, in blue shift, apparent frequency is clearly more than actual frequency. So f dash is equal to f into 1 plus V by C, which is f plus fv by C. So f dash minus f is equal to fv by C implies f dash minus f, that is apparent change in frequency delta f, divided by actual frequency f is equal to v by C. So this is fractional change in frequency with respect to the original frequency. Similarly, for wavelengths, lambda dash is equal to lambda into 1 minus V by C. In blue shift, apparent wavelength decreases. So that is lambda minus lambda V by C. So lambda dash, or rather I will write lambda, this I will take it to LHS, lambda V by C is equal to lambda minus lambda dash it will be. That implies delta lambda by lambda is equal to V by C. But clearly here lambda dash is less than actual wavelength. Apparent wavelength is less than actual wavelength. So such formulae, such shortcut formulae, this is, if I can write, this will be delta dash, this will be delta f dash, apparent change in wavelength, that is actual change in wavelength. So that is how it can be denoted and used for shortcut in solving problems.